So this is M47, photochemical smog and acid rain. So on this page, 548, up at the top, what causes VOCs in the atmosphere? So volatile chemicals, what causes those? What do we do to put those into the atmosphere? And there are a couple naturally occurring VOCs, but most of it is human-caused. And then describe how the presence of VOCs contribute to NOx, inability to break down tropospheric ozone. So how can those volatile chemicals in the atmosphere contribute to nitrous oxide's inability to break down tropospheric ozone? So I know that's a lot of words there, but understand how that works. And then down at the bottom, how does a thermal inversion occur and how does it create an inversion layer? So this is key to smog forming and staying within the city. So sometimes you might drive down to Sacramento and you see a really heavy smog layer, hard to see the buildings. And then other times of the year, maybe even the next day, you drive down and the buildings are super clear. The pollution levels may not be different from day to day, but the temperature inversion or the layer of atmosphere above the city might be a lot different, and that's what's causing that. So understand how that thermal inversion occurs. And then over here, understand these diagrams. Make sure you understand the chemicals that are involved, what's happening. And then I put the sticky note up here. How is stratospheric ozone depletion and ground level ozone different? So one is a beneficial ozone and one is not beneficial. Stratospheric ozone depletion, that's occurring daily. So the ozone is breaking down and reforming every day, but ozone in that layer is good. So that's where it belongs in the stratosphere. But when it's at the troposphere level, which is our level, how is that different? And then this is a good equation to remember. You can just remember as NOx plus VOX plus ozone, which is O3, is photochemical smog. So that's something that obviously is not good. So just remember that equation there, and that'll help you remember how smog is formed. And then I put here, this is how tropospheric ozone occurs. So we've got nitrous oxide plus regular oxygen that yields another form of nitrate. And ozone. And so that's what's considered to be tropospheric ozone. So understand how that works, and that's pretty much this C, figure 47.1C. So just be familiar with that and understand that's probably going to pop up several times on the AP test. And then going to page 550, what pH is considered to be acid deposition? So what is the pH range, or what is it below that would be considered actual acid deposition? And then how does acid deposition form from lead specifically? So how does that occur? It forms from other things too, but specifically lead. And then why is acid deposition improved? So we have seen an improvement in the US, and why is that? So specifically, why is that occurring? And then on 551, describe the negative effects of acid deposition. So what are the negative effects? What does it cause? What do we see happening from an excess of acidity in rainwater? And that concludes 47.